Okay, this video is going to be a quick video on arithmetic sequences, which in our algebra class is targets 19 through 22. There's an explicit rule and there's a recursive rule. Okay, so the whole idea is it's a different kind of notation. For the explicit rule, we are writing what looks like an equation and it just has a little bit different notation. Okay, and this is what the formula looks like for an explicit rule. All right, so this is saying n stands for the term number. You would enter, if you're looking for a certain term number, you'd enter it in there. These things that show always match. I'll get to that in a minute. But first of all, when you're writing an explicit rule, like if you look at number 2 on your review worksheet, if this was my sequence, was -3, -1, 1, 3, 5. Okay, so if this is my sequence, the two things I want to identify, and this is going to go for any arithmetic sequence, and then when we come up on targets 23 through 25, which is geometric sequences, we're going to be identifying similar things. But this is the first term. Whoop. Okay, first term, that's what that really says. But yeah. Okay, first term. So in this case, I can look at this and I know A1, this 1 stands for first term, equals -3. Now, the other thing is, for it to be an arithmetic sequence, I have to look at what this is changing by. This is going up by 2, up by 2, up by 2. Okay, now if it wasn't going up by 2, or adding 2 each time, it wouldn't be an arithmetic sequence. So I mean, that's a requirement, that you're adding or subtracting by the same thing every time. Now this is what we call the common difference. It is going up by a +2 every time. So I say for your D, what is being added or subtracted? Okay, so now I have A1 equals, now my D, we have said D equals 2. So now to write my explicit rule, sorry, I'm making my camera a little funny here. To write my explicit rule, it would look like this. For any given term, or any n, would look like this. AN equals -3 plus n minus 1 times 2. Okay, so now I like to put parentheses behind here because sometimes if you're subtracting a number and there's a negative, I don't want it to look like we're subtracting this off the end. We are looking for, I like the parentheses to show that it's always going to be multiplication there. Okay, now we have what is called a simplified version. Now that's just simplifying all these numbers. And to do that, I'm going to distribute this 2. Because my order of operations says I need to do multiplication before I do the addition. So this turns into -3 plus, now this is going to be 2n minus 2. I'm not done simplifying that yet because this -3 and -2 can be combined. So now an equals 2n minus 5. Okay, so this is what I call the simplified version. Now, you won't necessarily have to simplify it, but on the review and on the test, I'm going to give you the simplified version, and you will have to find what the difference is, and you'll have to find what the starting term is. Now, if we look at it, up here we identified D as 2. Okay, so in these ones, whatever is with the n is the difference. So by looking at this, I see that D is 2. We've already determined that above. Okay, but up here, look at, we have A1 identified as -3. Can I just look at this and see a -3? No, I can't. So a lot of students make the mistake of saying, oh, -5 is the starting term, but it's not. What I need to do to find the starting term is put in a 1 for n. So if I did 2 times 1 minus 5, 2 times 1 is 2, minus 5, and voila, there we go. A1 equals 3. or the first term, a sub 1 equals negative 3. Okay, oops. Hopefully you can see that. All right. So this right here is a lot how students write it. Now, if you're asking for the 100th term or the 50th term or whatever, the n stands for whatever term you're looking for. So if I was looking for the 50th term, I would put 50 in here, 50 minus 1 times 2, and then I'd add a negative 3. That would give me what the 50th term is. Okay? Now, let's go to the recursive. The recursive rule, if really the only thing it's good for, is to look at it right away and determine right away what is the starting number in the difference. So this is what the recursive rule looks like. A sub 1 equals, there's two parts to it. Now, I'm writing a line there because you need to fill in what it is. Okay, and then an equals an minus 1, and that n minus 1 just stands for the term before. If I'm looking for the 10th term, whatever that n minus 1 is the term before, plus the difference. Okay, so every recursive rule you write should look like this, and you're going to insert starting number here. And then here, insert difference. Okay. Now, this is plus the difference. Sometimes you will have a negative difference, so you could really do plus a negative 5 or whatever the negative difference is, or I just like to change this to, it'll be a1 minus 5, saying it's going down by 5 or it's going up by 5. Okay, so there's the recursive rule. Now, looking at this, you should be, if you have one, well, actually, let's go back over here. So this was my sequence. So what the recursive rule would look like for this would just be a sub 1 equals negative 3, because that was my starting term. And then I have an equals an minus 1 plus 2. So right there is what the recursive rule should look like. All right? So on your review, you should be able to go between the two. Now, the last thing I wanted to go over was a problem off of the review that have been giving a lot of students trouble. Okay, we're looking at number 4 here. Write an explicit rule for the sequence a sub 8. So that's saying the 8th term is 27 and the 17th term is 63. Okay, so this is a multiple step way to do it. So I'm going to rewrite these things as an ordered pair. Okay. 8 and 27, because really 8 is my input or my n, and then my output is 27. I tried to talk about x's and y's and stuff earlier in the year as inputs and outputs. So I have 2 inputs and outputs. Now I really have 2 points here. So input is this, output is here, input, output. Now these also look like x's and y's. If you were to write an ordered pair, it would look like an x and a y. The difference is kind of like the slope or the rate of change. I mean, it really is the rate of change of the sequence. So we learned earlier in the year, we had a unit on finding the slope between 2 points, and that's the change in y over the change in x. All right, so I'm going to do, so 27 to 63, that's really, how much does it change? 63 minus 27 over 17 minus 8. How much is it changing? All right, 63 minus 27, let's see. Math in my head, that sounds fun. 36, does that sound right? 17 minus 8 is 9. Okay, so 36 divided by 9 equals 4. Okay, so really, I found the rate of change between these, or the difference. What I just found was the difference of the arithmetic sequence we are looking for. Difference equals 4. So I'm trying to write an explicit rule, and just like any arithmetic sequence, I need to find the difference, and I also need to find the starting term. So I'm going to take this information, I'm going to just write a general arithmetic sequence here to help me organize my thoughts and information. Now, I'm going to go back. I just found D. We just said it was 4. Okay, so I can go in and I can say 4. Now, up here, I have an, up here, this is really saying n equals 8 and an equals 17. That's really the relationship between those. So I can insert these numbers back over here. So my n equals 8, 8 minus 1, we do not know the starting term, that's what we're looking for, equals, so all I'm doing is plugging in numbers I know. Okay, so now I have 8 minus 1, which is 7, times 4, I'm going to do the math, 17, okay, 7 times 4 is 28, a1 plus 28 equals 17. Now this just is an equation. I'm looking for a1, so minus 28 from both sides. It's just a mathematical, it's algebra that we're doing. 17 minus 28, oh boy, negative 11, does that sound right? Equals a1. So now I have identified my first term. Sorry, don't mind my circle here. I've identified my first term and my difference, so I can go back and write an explicit rule. Okay, so I have an equals negative 11 plus n minus 1 times 4. All right, and that is what I will conclude with. So again, I took these two numbers that were given to me. I wrote ordered pairs. I found the change in y over the change in x, which is my difference. I then plugged in everything I knew, because I knew the difference and I was given an n and an an. I plugged that in, used some algebra to solve for the first term, and that's how I finished it.